Hello everyone and welcome. In this video we are driving a very special and very unique Cadillac. This is the Celestiq and it is a flagship sedan from Cadillac and it's starting at around $350,000. So this is a pretty unique, pretty special product from Cadillac. They're only making 400 of them per year and it is built in Warren, Michigan, right by the Tech Center, which I had the opportunity to tour and check out and learn all about the engineering of this vehicle. It was a ton of information, so I'm going to go over some of the highlights from my trip to Warren, and of course we are now in LA actually getting to drive the Celestiq. Now, very quickly, I just want to get through the basic specs. This has an 111 kilowatt hour battery pack, good for the EPA rating of 303 miles of range, so they were targeting at least 300 miles of range. It's got 655 horsepower from two motors, one in the front, one in the back, and 646 pound-feet of torque, good for 0 to 60 in 3.7 seconds. All right, we've got the specs out of the way. Let's chat engineering. So one of the really interesting things when it comes to the production of a vehicle like this with very low volume is that you do things very differently. So if you're trying to make a lot of a part very cheaply, well, your initial investment tends to be very high, and then you can get that part cost very low. But if you're trying to make a few parts inexpensively, well, if you were to make that huge initial investment, the per part cost is very high. So you have very different manufacturing techniques that you use depending on volume. And since they're only making 400 of these a year, the volume of the parts involved is very low. So there's so many different strategic choices that they use in creating a low volume vehicle like this. It's a lot more like producing a prototype than, a mass-produced, high-count production car. So I want to walk through 6 of these examples, and the first one being the internal structure. So they're actually using massive aluminum castings, and this might remind you of, hey, Tesla's used massive aluminum castings, right? Well, actually, the same prototyping company that created these prototypes, has created these prototypes for Tesla in the past, was bought by GM, and they're using that company to create these 6 massive castings that are used for the internal structure of this Cadillac Celestiq. Now, this is actually done using sand casting for these prototypes, whereas in a much larger scale, you might see die cast, high pressure die cast castings. And what was surprising is that GM was saying, actually, with this sand casting method of this company that they own, they do it bottom up. They feed the molten aluminum from the bottom up in these sand castings, and they're actually able to get really close to the same material properties as doing it with a traditional die cast method. All right, so why wouldn't you want to use this sand casting method at scale? Well, it's very time consuming, right? There'd be different methods you want to choose, but then also it's very time intensive from a finishing standpoint. So there's a lot of machining that has to go onto these castings, and yes, you get to reduce your part count, but there's so much machining that needs to happen on it. So it's a very time intensive thing to create this internal structure. So you have these 6 massive parts. This cuts down enormously on the total part count of your vehicle. Then with these 6 massive parts, you're going to use a bit of welding, some bolts, and then of course a ton of structural adhesive to get them all together, heat that up, cure it, and then you have this very rigid structure that's left over. In fact, Cadillac says that this is the stiffest internal structure of any GM product. And so that's really cool because a really stiff structure is good for many reasons, but one of the big ones is that it allows your suspension to do exactly what you ask of it. So if you have this really wobbly body, then okay, you can have the best suspension in the world, but if your body doesn't allow it to be put to work properly, then it doesn't matter. So here you're starting off extremely stiff, extremely rigid, and then you can work some magic with the suspension, which we will get into. Now, you'll also notice this huge tunnel running down the center of the casting. So this is a 4-seater. It was always kind of planned to be a 4-seater, so it has this transmission tunnel, so to speak. If you want to LS swap it, it looks like it's ready to go. Now, why does it have this massive tunnel in the center? Well, it's to accommodate the battery, and the battery, of course, helping to aid in the stiffness of this overall. And the battery is another key discussion point on you're doing things very differently because this is a low volume vehicle. So if you look at GM's high volume vehicle, they're tending to use the same 100 amp hour cell. It's this very large cell. GM's battery strategy has been fewer cells as big as possible, right? Kind of reducing part count, trying to simplify things, improve reliability. Well, they're using those same cells in this vehicle, but normally if you look at other GM products like Hummer EV the Cadillac Lyriq, for example, you're going to take these cells, you're going to put them within a module, and then you'll have a certain number of modules within a pack. And all of those modules are the same, right? It's just a rectangular box with a certain number of cells in it, and you can use as many as you need to get the range you want. Well, with the Celestiq, they want a really specific body style and they want a low roofline. So just using this one conventional rectangular shape doesn't work for their goals. So there are 5 different battery modules instead of 1 to make it work within this unique battery pack. Now, on top of that, instead of these cells being vertical, they want a really low roofline here. So if the cells were vertical, well, that pushes everything up. So one of the things they've done is they've put the cells horizontal, so they're now laying like pancakes on top of each other. Of course, previously they were cooled with a cooling plate on the bottom, so now those cooling plates are running vertically along the sides of these cells to help cool them. But by using them horizontal, you can have different layering thicknesses throughout the car, right? And so in the back seats, where you want to have plenty of passenger footwell space, you've got those batteries laying horizontal, you've got more leg room, and you can still accommodate a really low roofline, which this has. Also, of course, using that transmission tunnel gives you a lot more space to stick batteries and increase your capacity so they can hit their target of 300 miles range. All right, so as far as the battery discussion, why not do this at scale? It's like, obviously you wouldn't want to have 5 different battery pack modules if you're creating, 200,000 of these cars. You're doing a very bespoke solution for this so that you can get the interior dimensions, so that you can maximize your use of space for something that's done at low volume. Yes, you've got a complex solution, but it allows you to hit these targets with whatever you want to happen within the car, where the passenger actually sees the space, interacts with the space. All right, moving on. Other manufacturing techniques we're using at low volume. 3D printing. So there's over 100 3D printed pieces within this vehicle. And I think often when you think of 3D printing, you might think of your 3D printer at home or at a university, and it's laying down this little bead of plastic. It's a very different style in the production manufacturing environment. So there's metal used, there's both steel and aluminum in here. In fact, this aluminum on the steering wheel is 3D printed. There is metal like these D-rings for the seatbelt. And so these seatbelt D-rings right here, actually, I'm told, are the first time GM has used a 3D printed part on a safety element of the car. So pretty wild. And I'm told also that that D-ring can hold the weight of 3 Celestiqs, and I think they weigh over 6,000 pounds. So quite a lot of weight that one of these little D-rings can support. Could it withstand me flexing? If I were to flex right now and just kind of, yeah, it could do it. Now, it's very interesting learning about how these 3D printed metal parts are made. I was there in Warren, Michigan at the Tech Center checking out some wastegate manifolds that were getting made. So these are made of Inconel, so they're able to withstand really high heats. Of course, being involved with the exhaust, with the turbocharger, these wastegate manifolds being 3D printed in Inconel. Really neat process. It lays down a layer of powder, then it goes back over that layer, vacuums up most of it, so there's a very fine layer of Inconel remaining. Then it laser welds that Inconel, those powder particles together, forming that wastegate manifold, and then you just repeat the process, right? You lay down a little bit more, you vacuum up most of it, laser weld it, repeat. So this really neat process, and what I'm told is that actually from a material standpoint, it ends up being very similar to other manufacturing techniques as far as the strength with metals. Now, not necessarily true with plastics. Plastics don't tend to be quite as strong 3D printed versus injection molding, but with metals, apparently you can get pretty close, which is quite cool, and all because, you're welding this. It's all gonna end up being this one metal piece at the end. Now, 3D printing offers some very real benefits in a low volume production scenario. First of all, it gives you a ton of flexibility, right? If you change your mind, you can make tweaks very quickly. But second of all, that means enabling customization is already there, right? So if a customer says, I want to put my initials or my dog's face or whatever on a 3D printed part somewhere within this cabin, they can do that, right? So there's a ton of flexibility in the manufacturing process in that you can make changes very quickly. Now, it takes a really long time. So these Inconel wastegate manifolds, they took about 30 hours, over 30 hours to make 6 of them, and it's over 2,000 layers that it's doing this laser welding. So, very fine layers, and of course that means it takes a really long time to make. So at low volume, that works out. If you're to do it at high volume, of course that's crazy. You'd be spending way too much time creating these parts. Now, they also do use a good number of 3D printed plastic parts within the vehicle as well, and it is different than, again, like laying down that bead. It's a different process, and the finish is much nicer. In fact, when I was holding these and touching them, it's like, oh, this doesn't look like a traditional 3D printed part to me. You can get a really nice finish on these plastic parts, which was surprising. All right, moving on to our fourth low volume production solution, we're going to talk about GM's Flex Fab. So traditionally, if you're going to make a ton of small metal parts, you might do that with stamping, right? Well, that involves very expensive tooling. And so here they have their own automated factory, essentially, where they can take sheets of metal and whether it's bend, cut, or punch, they can apply these processes. And for fairly low production numbers, you can make a ton of parts very quickly, like not massive, 100,000, but you can make in the thousands very quickly. So it's a unique process where you've got all these automated machines that can take a sheet of metal, bend it. There's in fact examples in the car where there's 16 bends on a single part. If you need to cut anything out of it, if you need to bend it, punch it, whatever, they have a process to do it very quickly, all in this automated factory, which is quite cool. And there are over 300 parts in this car using this process rather than going the route of stamping. Moving on, the hood, which I am told is the largest by size hood in GM history, is made of carbon fiber. And you might think, okay, well, of course, it's an expensive vehicle and you want to, use lightweight materials where you can. And sure, yeah, that is the benefit. But actually, carbon fiber here is being used for cost reasons. And of course, you get the benefits to go along with it. But reason being, if you're to use steel or aluminum and you have this metal stamping process, again, the tooling costs are very expensive versus carbon fiber at a low volume number, actually, because sure, it's expensive to have a carbon fiber hood, but at low volume numbers, it's actually cheaper than if you were to do the tooling to create a low volume of metal stampings. And it's not just the hood, there are other body panels that are also made out of carbon fiber, but an interesting note with the hood, okay, say you have a steel hood and you want to make it lighter, so you could go to aluminum, right? Well, one of the challenges with using aluminum on a hood is the pedestrian safety laws. And so aluminum will deform, right? So if a head is going to impact that hood, well, you have to make sure there's a big enough buffer underneath it so that when that aluminum does bend, you don't hit something really hard that's right underneath it, a control arm, or if there's an engine under there for a different vehicle. And so you have to have this large buffer. Now that means, of course, raising up that hood. Now with a carbon fiber hood or steel, but of course steel being too heavy, with a carbon fiber hood, that absorbs that energy much better and it spreads it out, and you don't have to worry about that tolerance. You can have a really close gap between the hood and whatever components are underneath it and still meet pedestrian safety laws because you don't have to worry about that thing crunching in. We're talking about low G forces here, if you're kind of falling onto the hood with your head. So you're not really worried about, okay, that's a quick deceleration. What you're worried about is you don't want it to hit something underneath it and then have that sharp deceleration. So actually, while it sounds a bit unintuitive, carbon fiber is a safer material than using something like aluminum. Now, the sixth and final manufacturing topic I want to talk about is the paint. The paint is wild on this car, and it is stunning to look at in person. So typically in pretty much any manufacturing process for painting, you're going to see orange peel. So you'll see these kind of visual deformations in the paint, right? It's not all this one unique sheet of this whatever color you've chosen. And here they've changed the manufacturing process, right? So it goes through paint, then the entire thing is wet sanded, and they have their own unique finishing process to ensure that, hey, when you look at this paint, like, you don't have orange peel. So a lot of thought into making it look the way it looks, but also some interesting functionality benefits. So in the back, there's radars all over this car. I think there's about 9 radar, but there's 2 long-range radars in the back that are looking at, for the Cadillac Super Cruise, okay, if there's a car flying up behind you and you're changing lanes, is it going to be able to detect that car way back there that's flying up at really high speed? So you've got these long-range radars in the back. Now, normally with long-range radar, you're going to have this plastic black gloss surface or matte surface over the front of it. It's not going to be behind a body panel, right? And so here, they are completely behind the body panels on the back. So if you look at the back, it's like it's all a painted surface, right? And there are radars behind that painted surface. Now, the challenge with paint is if you have a metallic paint with a lot of aluminum in it, the aluminum is what's giving it that sparkle, that metallic look, that aluminum interferes with the radar. And so they had to reformulate the paint so that they could still have this metallic appearance, but also not get in the way of the radar and distort what information that radar is bringing back in. So not only the paint formulation itself, but how it is painted, the process of how you do the lines of the paint is all important for ensuring that these radars work. So if you do end up changing a color and you choose a custom color for this car, they have to go through that whole process and ensure that it does work with these radars. So yeah, I mean, if you think about scale again, you're not going to do that on a car that you're making 100,000 of, right? You're just going to have that black in front of it, put it up front, not worry about anything with the paint as far as the radars are concerned. All right, so what about the driving experience? And I think the first thing that kind of pops out when you start driving this thing is the ride quality. The ride is genuinely exceptional, and there's so much work that goes into this. So it starts, of course, with that extremely stiff chassis, and then from there, you've got a lot of different levers you can pull on. So it has, for the springs, it's got an air suspension. For the dampers, you've got magnetic ride control 4.0, which they say is the world's fastest reacting active suspension. Then you also have active roll control. So now we've got electronic sway bars, electronic anti-roll bars in here. First time being used in a Cadillac, and this is a really cool technology. So active roll control, using these active sway bars, essentially you can change so much about the behavior of the car. So if you think about, okay, I'm just designing a car and this car has no sway bars. Well, then you're going to use pretty stiff springs because you don't want a ton of body roll as you go around a corner, right? But then you can say, well, I can use softer springs and then use a roll bar so that I don't roll as much, but then I can have a better ride with these softer springs, right? But then from there, you still have the influence of those roll bars in situations where you don't want them. Say you're hitting road irregularities in a straight line, hitting a pothole, something like that. You don't really want those two suspensions to be connected. You want them to be separate so that you absorb the bump as well as possible and you don't upset the whole car. Well, active roll control allows you to do that, right? So if this thing's going in a straight line and there's a pothole, it can actively force that tire down into the pothole and then bring it back up so that you don't have this huge hit that goes across the whole vehicle. And it keeps the body flat and it keeps the feeling, the sensation of driving along very smooth. So that's really cool. But then on the flip side, it can allow you to change the characteristics. So right now we're in the canyons and maybe you want to push it a little bit, give it some cornering. And what it does is in sport mode, it enables a 0-degree roll gradient, meaning when you turn the car really hard, it keeps the body literally flat, 0 degrees of roll. Now in a normal sports car, that might be somewhere between like 1.5 to maybe up to 3 plus in, sedans, things like that, things that aren't trying to be performance oriented. You might get in the 4.5 degrees of roll per G of cornering. And so here you can make that number 0 so that the body stays exactly flat. In fact, you can do whatever you want. You could force it while you're turning this way to actually roll in, but it's a little weird, so they just keep it flat. Then if you put the car in touring mode, well, now it's absorbing all these bumps. It's a bit more floaty. It's kind of magical as you're just going along. It's cloud-like. And yeah, you've got body roll when you corner, not a ton, around 3 degrees versus keeping it perfectly flat, but it allows for that duality in the driving nature of the car by having these active roll bars where you can flick a switch and say, okay, touring to sport. The body behavior is very different simply because you're relying on those anti-roll bars on how you want the car to feel. And another aspect of these anti-roll bars is you can immediately change the understeer, oversteer characteristics of the car. So whether you want it to push in the front or, kind of swing out in the back, you can keep that neutral balance by manipulating these anti-roll bars. So for example, if you were to make the front act really stiff, well, in that scenario, you're going to have understeer. If you make the rear act really stiff, well, in that scenario, you're going to have oversteer. And so you can have these tuned so that it gives you that neutral driving behavior by changing what these motors are doing front rear and ensuring that you get that neutral handling behavior when you're driving in a canyon like this and you want to give it a little push. So it's a really cool solution that just allows you to have 2 different kinds of a car in one. Super plush super sporty. Now, as far as the car overall, do I have any complaints, any concerns, that sort of thing? A couple things do stick out to me. One of which, of course, the interior is immaculate. It's a really nice place to be. There's really nice materials everywhere you look, whether that's leather, metal, wood. However, with all the metal everywhere, on sunny days like this, it seems like there's always one piece of metal that's redirecting the sun right at your eye, because there's metal everywhere, right? And so all of these shiny bits on days like today, you get to see the sun reflecting off of them all. So I'm not crazy about that. Now, another point I have to make, and I think this is more of an industry-wide problem rather than just looking at Cadillac, but I feel like it used to be the case that if you're buying a vehicle at this caliber, at this price range, $350,000+, they used to come with a very unique powertrain to go along with that, right? And here we're using motors from GM's available motors out there, very similar to what you would find in a Lyriq. So 655 horsepower, yeah, it's plenty. I mean, it's definitely a quick vehicle, and we're spoiled today in how fast cars are. However, it used to be, if you're in something like this, of this caliber, it's got a massive V12, or even if it's electric, if you look at like what Lucid's doing, if you go for the Sapphire, it has this really unique powertrain, unique to that Sapphire, that you only get with that Sapphire. And I think that performance aspect of it is missing here a bit, and that it doesn't have that really special powertrain that is just a part of everything's over the top, right? And so in this case, most things are over the top, and there's a lot of really cool engineering that goes into this, but the powertrain is pulled back a little bit, and it's like, okay, you can get this kind of performance in plenty of cars out there, especially in the EV world. That's not to say that 3.7 seconds isn't quick. Like, it's obviously quick, but I do miss that there's nothing really that unique and special about the powertrain. Now, it is different, right? It's not going to be the same as the Lyriq. There's more isolation, so you've covered up those motors so they're very quiet, different gear ratio, so you can tune the acceleration to what you want it to be. But again, we're using similar motors. Now, if you look at the Rolls-Royce Spectre, it's the exact same story, right? In fact, this has a larger battery than the Spectre, this has more power than the Spectre, this is quicker than the Spectre, and so it's like, the same strategy is done within this segment, right? Rolls-Royce is using BMW parts for the battery, for the motors. It's not this bespoke, unique powertrain like something like the Lucid Air Sapphire, where, oh, you're paying $250K, all right, you get this really cool powertrain to go along with the other nice features. And on the subject of the Lucid Air, here's another thing about this car, in that it is absolutely massive, right? This thing is over 20 inches longer than a Lucid Air, which is already a fairly large vehicle. The wheelbase is over a foot longer. The wheelbase is like 130 inches. I mean, this is Cadillac Escalade range for the wheelbase. And so you think, okay, you've got all this space, right? But like, if you look at interior space, legroom, 2.5 inches combined between front and rear, more than a Lucid Air, despite the Lucid Air having, over a foot smaller wheelbase. So interior space in the Lucid Air with a much smaller vehicle, very similar to this. Cargo space, almost identical between this, which is absolutely massive, and a hatch. They're calling it a sedan, but it has the hatch in the back. Almost identical cargo space between this and the Lucid Air when you combine its frunk and its trunk. And so the thing is huge, right? But the space utilization isn't quite as highly optimized as some of the other cars out there. Now, does the person buying this car care about that? I think there is plenty of space in that rear hatch. The floor is fairly high, but there is still a lot of space back there. But as far as the frunk, very tiny. It kind of looks like an afterthought. It's pretty small up there. So frunk is a bit small, but you do have cargo space in the back. It just seems like, for how big the vehicle is, and especially, up front where you've got the largest hood in GM history, and then this tiny little frunk, it's like, what's going on up there? Now, yeah, there's a lot of stuff up there. You've got, the active ride control, you've got the air springs, you've got the active roll control, and so there's a lot of technology that's going into this. But Lucid managed to find a way that I can fit my entire body up in the front of it, right? So, like, from a packaging standpoint, front is huge, but not necessarily providing you a benefit from a consumer standpoint of cargo space. Again, I don't know where I fall, because I'm a much more logical person person than perhaps the person who's making the emotional choice in like, what cars do I buy? And the person buying this probably has tons of cars already, so they're probably not looking at like, okay, what's the ultimate cargo space that I need in order for this thing to be perfect for me? But overall, the level of customization that is allowed with this vehicle is pretty bonkers. I mean, you're looking at this interior here, it's got 2 different shades of blue plus this orange red combo, and you can choose whatever you want to go on with these materials as far as the colors. So there's a lot of customization allowed with these interiors, and all the materials are really nice, right? Like whatever you look at, if it looks metal, like it actually is metal, so that's cool. A lot of this reminds me of concept cars when I look at it, especially when you look at just like the finer touches, when you open up the door, when you open up the rear hatch. It's like the level of detail put into the areas that you don't often see but that you can see sometimes is really way up there. Like they've put in a lot of effort into making sure everything is visually stunning. A great example being the radars behind the paint. Also, there's no door handles, so that looks very concept car like. I mean, I like door handles, but visually, like clearly it does look really nice not having them. There's a little button that you can push to open them, to close them. You can just put your foot on the brake and that'll close the driver's side door for you. They all have radar within them, so they know, hey, if there's something in the way, they won't hit it. And there are plungers within each of the doors so that, let's say you get a sheet of ice freezing it over, well, that plunger can punch the door out, so you don't have to think like, oh, I can't hit this button, how do I get the door open? It's like app on your phone, pop it out, no problem. So it is well thought out, despite not having buttons. You know, EVs have just gone this way of like, let's reinvent the door handle. So it doesn't have them, but visually, again, it makes it look like a concept car. So there's so many angles of this car, especially with that rear hatch up and looking at this car from the back, where it just looks like a concept car, and here it is, this is the reality, this is the production, what it's going to look exactly like. The highlight for me, definitely driving this thing, has been the level of comfort that it offers, and that the suspension is nuts, the ride quality is so good, especially in touring mode, and it's crazy quiet in here. The loudest thing is the air because it's hot outside, so I've got the AC on. It's like, that's what I hear the most, pretty much, is these AC vents, a little bit of tire noise, but honestly, it is so quiet in here. Really, really nice place to be, whether you're up front, in the back. The back seats are actually the exact same as the front seats, same controls, same identical seat, 22-way adjustment. You've got, you know, air massage features in there. So it's also cool that this is, you know, it's designed to be driven. You want to put it in sport mode, go around the corners, or it's designed that, you know, someone can drive you around. You get the same seating experience, and you've got plenty of legroom back there, plenty of space. So all of this starting at $350,000. I'm sure if you want to get crazy with your customization, you can make that number go way higher. And I'm curious to hear your thoughts on it. What do you think about the Celestiq? Of course, any questions or comments, leave them below. Thanks for watching.